Alright, I usually don't do this, but to start out this video on momentum, I did want to review a much more important topic. Just like I did in class, this is my warm-up when I first started this unit, and I want you to tell me as an object falls, there's more than one answer, which of the following are true? So we've got those options. Pause the video, look through, and write down what you see. Here's the answer. If you don't want to see it, pause. When an object falls, height is decreasing, right? It's going down, which means that potential energy is also decreasing. So, B. When an object falls, it goes faster and faster and faster. It's accelerating. So that means kinetic energy is also accelerating. So kinetic energy increases. And this is not true. The answer is F, and here's why. There's no change in the total energy of the system. All right, at the very top, let's say we have 300 joules of potential energy and 0 joules of kinetic energy. And then as it falls at the very bottom, we have 0 joules PE, and we will have 300 joules of kinetic energy. So as it falls, sure, we're losing one form of energy, but we're gaining it in another. Alright, so the new topic is momentum. This is a video of a really big football player, and we'll watch a little bit of it, just so you can get an idea about this guy, because he's got some, let's see, right about here, there's a really good example. Let's see if we can find it. There we go. Nope, sorry. Nope, sorry. Alright, he's hard to tackle. Nope, still not enough. Touchdown. Where's the other one? Yeah, this one's it. This is the really good one. So watch this run. Nope, you're not strong enough to tackle him. You guys aren't strong either. Nope. Nope. Still no. And no. Okay, you get the idea. Okay, this guy, Mike Allstott, was a running back in the 90s for the Tampa Bay Buccaneers. He's pretty awesome to watch because, well, come on to the very end. Can I get there? Nope. Okay. Unlike most running backs, he's really big. But unlike most big guys, he's really fast. And this is what momentum is. It's a combination of how big are you and how fast are you going. So what does momentum tell you about an object? And you can use the momentum formula. If you're taking these notes for the first time, they should be on 20 or 19. But the definition for momentum is a measure of moving inertia. How much force does it take to stop something? But here's the best part. Moving inertia. Because let's look at our formula. Alright, momentum, there's your formula. And the letter P, we'll just ignore this. The letter P, M was already taken for mass, so we use P because of the pre-spelling. So momentum equals mass times velocity. Okay, inertia is related to mass. The more mass you have, the more inertia you have. An object at rest will stay at rest, and the more mass it has, the harder it will be to move. An object in motion will stay at motion, and the more mass it has, the bigger tendency it has to stay moving. And then the moving part of this definition, moving inertia, well, there's velocity. So it's moving inertia mass times velocity. Also that you need to know, let's clear this up, looking a little messy, about this formula. These are equally related. If mass doubles, momentum doubles. If velocity doubles, momentum doubles. So they're equally related, and the units are kilograms mass times meters per second velocity. So if you, we'll see in a little bit that you just leave the answers like that. We'll ignore this review. Alright, so write down this basic example. The first thing I'm going to ask you to do to get a C is just use the momentum formula. For example, pause if I'm going too fast, but write this down and do what I do about the information. We have a 1,000 kilogram car, velocity of 5 meters per second. What is the momentum? Given. Momentum equals mass times velocity. That's our formula, sorry. We know that mass equals 1,000 and velocity equals 5. So we do 1,000 times 5. Momentum equals 5,000. Now here's our units. Mass is in kilograms times meters per second. Okay, that's a basic example. Another basic example. This is more like what you'll see on the test. Put these in order from most momentum to least. So pause the video and multiply each one. All right, momentum. Find the momentum of each, and then put them in order from most momentum to each to least. We have. Here's the answer. Alright, so the order was B, C, A, D. Mass times velocity for each one. Okay, example number 2. Given multiple masses, predict the greatest velocity. If each object has the same momentum, which object has the most velocity? So pick one. Here's your answer. Let's ignore these two for now. Let's say the momentum equals 100,000. So the bike has momentum of 100,000 and the train has the momentum of 100,000. Let's solve for the velocity of the train. Equals mass, 50,000, times velocity. So you divide here, and you get v equals 2. So the velocity of the train is 2 if the momentum is 100,000. And let's say the bike, 100,000 equals 6 times velocity. So now you divide by 6. As you can, this is going to be a gigantic number, and basically, in order for a bike to have the same momentum as a train, this bike needs to be going very, very, very fast, or the train needs to be going slow. So that'll be another type of basic question. Given multiple masses, predict the greatest velocity. Okay, now impulse. So I have a question. What's the difference between going 60 miles per hour and gently pressing the brakes to stop, and going 60 miles per hour and running into the wall? And I specifically want you to tell me about time to stop and force to stop. In this example here, gently pressing the brakes, you're going to have a small force. But it's going to take you a long time. But when you run into a wall, you're going to feel a humongous force, and you're going to stop. The nice thing is, or maybe not so nice, you're going to stop very quickly. And this is impulse. It's a combination of force and time to stop an object. I'll go back to that. So, next part. This is the proficient part we're on now. Impulse. And we have two things, impulse force and impulse time. It's the force to stop an object, or simply just to say to change its momentum. And this is the time that the force was applied. To change an object's momentum. And your formula is impulse equals change in momentum. Force times time equals change in momentum. And by the way, kilograms times meters per second. Right? This is in seconds. So that means your time over here also has to be in seconds. If I give you time in minutes, you need to fix it. Let's look at an example. What force must be applied in order to decrease the momentum of a 600 kilogram meters per second in 2 minutes? Alright, so I know that change in momentum, it decreased 600 kilogram meters per second. Time equals 2 minutes, but that needs to become 120 seconds. And we need to find force. Force times time equals change in momentum. Force times 120 equals 600. And then you solve for force. 5 newtons. Very nice. So you try one that's harder now. What is the difference in force? So we want to find the difference in forces that a car going 200 kilograms going 20 meters per second and then comes to a stop. So let's break down this part first. Okay. It started with 4,000 kilogram meters per second of momentum, and then it ended up with 0 because it came to a stop. So we know the change in momentum equals 40,000. Now, we have to find two forces, force hitting the wall and force with the brakes. The wall feels a stopping time of 0.2 seconds and a change in momentum of 40,000. Gently hitting the brakes feels a stopping time of 10 seconds and feels a change in momentum of 40,000. I want you to find the difference between these two forces. In order to do that, you have to solve for each force first. So for example, force from the wall, force times time equals change in momentum. So force hitting the wall equals 200,000, because you divide by 0.2, divide by 0.2, and these cancel. Now I know force here, force from the brakes times 10 equals 40,000. Divide by 10, divide by 10, cancel. And this force is 4,000, but I'm not done. What is the difference in force? 196,000. Okay, so go on the website and open up a file called Momentum Practice. And I want you guys to Momentum Practice. I want you guys to I want you to go through those problems, and there's also a version with the answers.